1 hour. Right. Very good evening, everyone. Welcome to this session on TS GENCO AE examination pertaining to electronics branch. Myself, Sharwan Kumar, IES 2011 batch, a faculty of ACE Engineering Academy for Signals and Systems, Networks and Communication Systems. So, today's session is a very short session, 1 hour session, where I'll be explaining you about the syllabus that we have for electronics branch for this AE examination in GENCO papers, and I will walk you through some questions which were given in previous papers. So half of the session I will tell you how to do your preparation in the coming 45 days, around 6 to 7 weeks, and how to maximize your score. So students, be very clear, this is a life-turning job. Once you get selected in this, you need not see back. The salaries you are getting are very good, and the level of promotions you are getting are also very good. It's a life-settling job. So try to focus as much as you can in the coming 6 weeks. Even though you have taken coaching or you did not take coaching, it is immaterial, because whatever you do in this coming 6-7 weeks will decide the remaining part of your life. So try to focus as much as you can on the subjects that I am going to tell now. Whatever the syllabus that is given to you, I have taken that and I have given subject-wise priority. Which subjects you need to cover first, what is the possible weightage, how in what topics you may get more questions. So I am giving you a planned preparation for the next 6 to 7 weeks. So use that to the maximum extent possible, and I will also discuss some questions which were given in latest papers, so that you will have an idea to what extent you need to do your preparation. Okay, so let us kick start our preparation strategy. Now, so this is a scheme of evaluation and syllabus. First, let us see what is the scheme of your question paper. So your question paper consists of two parts. One is core subject, that is your electronics branch, and the second one is general. So general in the sense it contains aptitude, it will contain questions related with normal English language. That means these articles, prepositions, fill in the blanks, a small part of that might be added. So that is what you are getting in this general awareness and numerical ability. And maybe 2-3 questions may also come from how this Telangana state has come into existence, what are the important movements in forming that particular state. So little bit of formation of Telangana might be also asked. They did not mention in the syllabus, but it may come. So you have to concentrate on numerical ability, English, as well as formation of our state. So these are the things that you need to concentrate here. Okay, so core subject is your electronics branch, and this is a general part. Now coming to the weightage, total number of questions that they are giving are 100. Each question is carrying 1 mark. So 100 questions, 100 marks, and the total duration is 120 minutes. That means you have to attempt 100 questions in 120 minutes, just over a minute per question. So you can clearly understand the questions that they are asking are not too much numerical. Otherwise you cannot do it in 1 minute time. It will be numerical, but not too much. So little bit of formula based and little bit of your smart thinking will also help you. And you have to cover the entire subject. It is not a gate exam. If it is a gate exam, even if you prepare 5 or 6 subjects perfectly and go, you can crack. But this is not like that. You will get questions from all the areas of your syllabus. So try to focus on the total syllabus as a whole, and then you try to answer them to the maximum extent possible. Is it clear? Now, let us first see the overall syllabus given to you. So this is a total syllabus. Okay. So first is the basics of circuits and measurement systems. So for electronics branch, if you take a pure electronics and communication branch, some part of your syllabus is actually coming from the measurement branch as well as electrical branch. So you need to focus on those subjects extra. Whatever you have studied in your engineering as a part of ECE branch, or you might have prepared for other competitive exams, that subject is more than sufficient to crack this exam. But additionally, you have to prepare some subjects coming from measurement side as well as coming from electrical side. So you can see the heading, Basics of circuits is completely electronics branch, network theory or network circuits, whatever we study. The other part is coming from the measurement. So it's a combination of these two things. So you can see the syllabus also. He is talking about Kirchhoff's laws, means your KCL, KVL, Ohm's law, and what is mesh and nodal analysis. Basic circuit theorems like superposition theorem, Thevenin theorem, maximum power transfer theorem, formula related questions only. Don't go in depth, okay? And then 1 port and 2 port network functions. It's basically our 2 port networks, Z, Y, I mean the impedance, admittance, and then the remaining parameters. Now the remaining part of the paper is a measurement part. Static and dynamic characteristics of measurement systems, how you do calculation of error, and how you do analysis of curve fitting. These are the areas, but this is taken from the measurement side. So especially when you are studying this, first part is known to you. The second part, please focus. Don't think it is not there in my engineering curriculum, I may leave it. Don't do that, because people who will get job will cover this part of the remaining syllabus, because they are very, very important. You have to attempt all the questions. Now, see the next one. Again the same logic. Transducers, mechanical measurement, and industrial instrumentation. So totally related with the instrumentation branch. So you have to concentrate more on this area. Don't leave any part. Then the biggest one, analog electronics and digital electronics. In our engineering, this is electronic device circuits, analog circuits, as well as last one, digital electronics, means switching theory and logic design. So it's a combination of these three things. Means you have to start with adders, subtractors, that all the gates, gate families, okay, and how you are constructing basic circuits using that, minimum number of logic gates required, these type of things, okay. Once you complete that part, then comes our electronic devices circuits, means fundamentals of diodes, transistors, JFETs and MOSFETs, and then about the questions coming from the analog side, means feedback amplifiers, these sort of things, all these are covered under this part. So this will take more time, and also it is more scoring, because most of the questions at least out of that 80 questions which is saying from the core sector, you might expect 5 to 8 questions coming only on this area. So my feel is there is a lot of scope in this particular case. So that's the reason when you are doing the preparation, I have given the order also, I will first keep this as a subject, because there is a chance of more weightage from this particular subject. Now, next. The next part is the signal systems and communication. This is also basic ECE branch. So it is covering two subjects. One is signal systems and another one is communication systems. So in signals, you have a basic definition of signals, convolution procedures especially, correlation procedures, and what is the response of an LTA system, causality, stability. All these are mentioned here, check carefully. Periodic and aperiodic signals, then impulse response, H of t, and transfer function and frequency response of first order and second order circuit, convolution and correlation, and response of LTA systems. And when it comes to discrete time domain systems, filters, FIR and IIR. But I am telling once again, don't go in depth. If you go, you are wasting your time. You have to cover all the topics with the formulas, because most of the questions will be formula based. And see the second part. The second part is your communication. He is dealing with amplitude and frequency modulation. So amplitude means what? It covers all the things, DSB, SSB, standard AM, even with VSB. And also he is covering a frequency and phase modulation, non-linear modulation as well as linear modulation schemes. And then when it comes to digital communication part, he is covering pulse code modulation. You are having here sampling process, PCM, and then different multiplexing techniques, and binary ASK, binary PSK, and binary FSK. That is the last part. So basically it is combination of three subjects here. One is signals and systems, another is analog communication, where you are dealing with AM, FM and PM, and digital communication also two parts. One is a baseband, which covers your PCM, and another is band pass, which covers your ASK, PSK and FSK. But all are fundamental things only. He is not going in depth. Very clearly mentioned in the syllabus itself. So you need to understand what are the power calculations, bandwidth requirements, and simple numericals related with these formulas. That is enough for you to cover the signal systems and communication part. Now, coming to the next one, electrical and electronic measurements. Again, measurement subject. So you can see how they mixed up different branches here. And then control systems and process control. Again, this control systems part is a part of our ECE branch only. So all the stability criterias, whatever we have studied there, signal flow graphs, all these things are going to come in that particular subject. Next, analytical and optical instrumentation. Again, this is purely an instrumentation branch. So here he is covering mostly questions related with optical sensors and optical sources. Optical sources means what? You will have LEDs and lasers, and detectors means you will have pin avalanche photodiodes. So most of the questions coming in the examinations are related with that particular area. And then you are having telecommunication switching systems and networks. These subjects actually comes in your final year. So what are the basic switching algorithms? Like you have a mobile, you are doing a message, normal message, I am not talking about WhatsApp. If you do a message, how that message goes from the transmitter to receiver? What are the algorithms that they are using there? What are the type of switching actions, like is it packet switching or any other type of switching? And if you are using algorithm, like signaling algorithms are there, SS7, such type of algorithms, what algorithms you are practically using there? And what about error correction, error detection? And if there is a traffic, how the traffic congestion is handled? These are the fundamental things coming under this particular subject. So most of the engineering students, they might not have full command on this subject. It's purely theoretical, but very scoring for this particular exam. And definitely you can get 3 to 4 questions from this area. So don't expect the questions to be numerical. They will be theoretical, and that too very easy questions. So don't leave these type of subjects. And last one we are having is again basic electrical engineering. So already we covered networks, along with that whatever the electrical machines we have, like and how resistance is varied, torque calculations, these type of things are coming in this last subject. So I can very clearly tell you it is a combination of 3 branches. They are combining electronics branch, electrical branch, as well as instrumentation branch. So focus is given to all the 3 branches. In ECE branch, whatever we are having, like network theory part, and then signals and systems part, communication systems part, and finally control systems part, EDC and analog, digital. So these subjects are combined and it forms the crux of your syllabus. Along with that, he mixed some subjects related with instrumentation, optical instruments, measurements. So these are the extra areas that you need to concentrate. So as per your grip on the subject, try to divide the time slots, because the next 45 days, 6 to 7 weeks is very, very important for you in your preparation. So try to spend as much time as possible. So if you are a student, it is good. If you are working anywhere also, try to take some leave, okay, whatever the leave that is possible to you. If it is not possible also, try to filter out your working hours. At least we require 7 to 8 hours a day. So even if you study 6 hours and keep 2 hours for revision, that will be fantastic. So my best plan is keep 5 hours for covering core subject, 1 hour for covering that reasoning, aptitude, maths, English, whatever it is. So 5 plus 1 will be 6, and 2 hours for your revision. Revision may not start initially from the first day. So once you keep on completing subject by subject, at least topic by topic, you need to spend some time on revision. So that is the reason, initial phase there may not be revision, you can spend that in covering the core subject, but later on allocate at least 1.5 to 2 hours for revision only, because whatever you study you have to remember, and that too hell lot of a syllabus. You are having so many theory questions, you have to memorize them without any second way, because numericals you can attack and do, no problem, but theory part is very, very crucial in these type of examinations. That will decide your rank. A small change in your score, you might not get your posting location also, because your locations are also dependent on your ranks only. So try to focus as much as possible. Okay, so whatever you know, try to spend less time on that. Whatever you don't know, means the electrical subjects and the measurement subjects, try to focus more time. And that too, questions related with theory are coming. So you need to write down the bullet points. what are the most important points, and how the questions are coming on that particular area. So that will be sufficient enough for you to cover these things. So your preparation is 5 plus 1 plus 2. 5 for core subjects, 1 hour for analytical, numerical ability, that English part, and the remaining 2 hours in the coming days for theory part. So try to focus in this way, success will be definite. Okay, so it can be students or it can be working class of people, whoever you are writing that exam, this is the best way of the preparation for that particular exam. Now, I have given you the syllabus. Now, I have taken this syllabus and as per my understanding and my experience, I have classified the syllabus in the order of importance. So that does not mean that you have to leave the last one. I am strictly saying you have to cover the entire part. There is no doubt on that. But focus one by one in this order of priority, because most of the questions weightage will be as per this order. Okay, that is purely my expectation, but with my experience I am able to do that. So try to focus in that way. So this is what I have shown here. Study plan for 45 days for your electronics branch. So all the 9 subjects I have listed out, but I did not take the same order that is given in the syllabus. This is the order that best suits you. First one is analog electronics and digital electronics. Maximum questions can come from this area. Syllabus is huge, weightage is also huge. So the time I am allocating is also very heavy for that. Okay, then the second part is control systems and process control. Why I have taken sure shot questions. You know how good you are at control systems, formula based, very simple. So attack immediately and get the answers. Time is very important and I have allocated 50 hours for that. Then the third one is signal systems and communications. Very good and interesting area. Good numericals can come from this and sure shot questions even from this area, because it is completely related for your branch only. So I have allocated some 70 hours for this subject. Then fourth one is basics of circuits and measurements. Means it covers your Ohm's law, nodal, mesh, KCL, KVL, network theorems, two-port networks, and little bit related with your measurements. Again, sure shot questions. So if you are able to complete these first 5 without making any mistake and without leaving any topic, there is a very good chance for you to score heavily. That is the reason my first priority is these first 5 subjects. Very important, I am telling once again, don't leave anything from this area, even it is theoretical or numerical. Okay, so I have allocated hours for the subject also, you can see there. So daily if you are able to do at least 5 hours, leave about analytical and revision. So this should cover you at least 3 to 4 weeks you would be covering this part. And as per your speed, if you are able to do it more quickly or some part of the subject you already know, try to do it more faster. So try to cover as much as possible in the first 3 to 4 weeks. Okay. Now coming to the remaining 6, 7, 8, 9, the last 4, these are much more related with the measurement side. So you have to prepare notes for that. And why I kept here, because the later you study, the better you remember, because your exam date will be nearing to that particular part. So most of these are theoretical questions. So try to focus more on the theory part, write bullet points and keep on memorizing them. And revision period in these last 3 weeks for these subjects is very important, because you need to memorize them. So see the subjects: transducers, mechanical measurement and industrial instrumentation, purely instrumentation subject. Then electrical engineering, again motors generated, electrical subject. And analytical optical instrumentation, again instrumentation. And last one is completely theory. So what message logics you will use, what are the algorithms we are using, what are the protocols we are following, what are the control algorithms we have, all these things will come here. So as per that I have given the time also. So my intention is the first 5 are very important and they may take little more time, but they are at the same time very scoring. At least 60 to 70% of your question paper may be on the first 5 subjects. Remaining 4 purely theoretical. So keep that points in mind when you are doing your preparation. If you are already good on some subjects, you may change your order. It is not necessary that you have to follow order given by me only. If you already know some subjects, focus on the things which you don't know earlier. that depends on your own interest. Okay, right. Now, coming to each and individual topic, what are the areas that were given in your syllabus and what are the important expected questions? See the first one. So I have taken that same analog electronics and digital electronics, means it covers EDC, analog as well as digital. So see the first part, digital electronics. Cover this is the easiest one. Out of 70 hours, I have allocated 22 hours here. So this completes all your Boolean algebra. What are the basic gates, universal gates, half adder, full adder circuits, combination circuits, sequential circuits. And most of the students are comfortable in this. So try to start with this area so that it becomes easier for you. Your confidence levels also a little bit increases. So these are the areas I have mentioned here. And you can see the important questions that can come from this will be from address multiplexers, counters and analog to digital converters. So these are the areas where simple numericals that can be solved within a minute can be given. So this is your entire syllabus. When you focus on revision, focus on these points. Whatever the formulas that you are writing, just revise them, that will be helpful. Now, coming to analog electronics. So it covers starting from diodes, FETs, JFETs, MOSFETs. All these areas will be covered under this area. So that is what is mentioned in your syllabus also. Semiconductor devices, diodes, BJT, JFET and MOSFET, operational amplifiers, very important, multi-stage amplifiers, feedback amplifiers, converters, voltage to current and current to voltage, active filters, means a filter circuit followed by an op-amp, and instrumentation amplifier. So from this also you can pick these important things. So you have to cover this, don't leave anything. Once you cover, when you do your revision, give priority to these areas. So one question you can expect from operation amplifiers. Not only in this, any exam, one question from ideal op-amps is pakka. So that is one area where you can concentrate. And the H parameters of your three-terminal devices, HIE, HOE, HRE, beta, alpha, these gains for CE, CB, CC configurations and capacitance values, standard parameters whatever you have in terms of comparison, that will come under BJT and biasing. It is not only related with BJT, they can ask on JFET as well as MOSFET. So try to make a comparative study in that particular region. And then we have multi-stage amplifiers. Okay, like Darlington pair is there. So how you are having that coupling, CBCE coupling, CECC coupling, CCCC coupling, how we are doing coupling for multiple stages to get more gains. So direct questions are sometimes coming on that area, overall gain of that amplifier. So those formulas, if you remember, easily you can attempt these questions. Clear? Now, coming to the last part in this subject, it is microprocessors. So don't expect too depth questions. That means taking instructions set, taking a number of T cycles. I am not assuming that the questions will be at that level. They can concentrate on data lines, address lines, and basic questions related with microprocessor. So it will be basically on interfacing, memory and microcontrollers. So just have a fundamental idea on microprocessor. That would be sufficient. Okay. So these are the areas coming under our first subject, first priority subject. Totally 70 hours for this subject. So try to use the best of your time and complete all the areas. Now, coming to the second one, control system and processes. So why I have taken this as a second one? It is also the same reason. Score is a maximum in this subject. Control systems, every student is favorite. Okay. So these are the areas that are mentioned. I have allocated 50 hours. Some students may not require this much also. If you are good at it, you can reduce that time. So you are having a what is the meaning of a control system? Signal flow graph, time domain response, all the parameters, and then root Hurwitz criteria, root locus, board plot, polar and Nyquist plot, all are stability analysis criteria. Then different type of compensators we are having, like lag compensator, lead compensator, lag lead compensator, all these things, and state space analysis and fuzzy controllers. Last two are little bit heavy topics. You may not get a question in these type of level examinations, but the remaining 8 formula based, don't leave anything. And I have given, these are the areas where you can focus: time response, RH and signal flow graphs. So once again, very easy and scoring topic. So don't leave this. This is the second priority subject. Now, coming to the third one, purely ECE branch, signal systems and communications. So again, I have taken as 3 parts. First one is signals and systems. Second one is digital communication under analog. Third one is digital communication under digital. Okay, 2 modulation schemes, total communication systems. Now, when it comes to signals and systems, these are the focus areas. LTA systems, series, transforms, convolution and filters. And these are the areas where you can expect very good numericals. Convolution also very simple, like convolution of 2 step functions of equal width or 2 step functions unequal width. What is the shape? From where it will start, where it will end? What is the total area of the convolved output? These type of questions, it does not take much time. Only reading question will take time. Immediately you can answer like that. So such type of things will come on these areas. Sampling frequency for the given signals, transformations of basic signals and filters. So these are the areas of your focus. And I don't expect the students not to have basics in this. Definitely every student will have little fundamentals on this topic. So don't spend more time. 25 hours is the maximum allotted time for that. Now coming to communications. In communications again you are having analog part and digital part. In analog you are having AM, I mean the standard AM scheme, then we have DSB, then we have SSB, and then we have VSB and FM and PM. All these modulation schemes come here. So all questions related with power, spectrum, bandwidth, these should be on your fingertips. So what is a modulated signal expression for every scheme? Then what are the power requirements? How you are drawing the spectrum? From the spectrum, how you are determining bandwidth? Only questions can come in this area. There is no other chance. So very, very clear. Try to score maximum. That's the reason I have given here very clearly. What are the areas you have to focus? And then when it comes to digital communication, basic PCM system, binary ASK, binary PSK and binary FSK. So just make a comparative study on this and try to attempt the questions coming on that area. So normally in GATE examinations, these are very huge topics. So such type of questions related with constellation plot, probability of errors, these type of things I am not expecting in this exam. Mostly questions coming will be related with bandwidth. Okay, so try to focus more on that particular area. So that is what I have mentioned here. Is it clear? So these are the areas related with signals and systems and communication area. Third priority subject. Next, fourth one. So this is the basics of circuits and measurement system. Again you are having this KCL, KVL, nodal, that part. And then AC circuit analysis. Means AC circuit analysis means how your circuit will react when your source is periodic sine or periodic cos. Because R, L and C elements are linear, how your circuit behaves when you are giving excitation as such a function. So that is your AC circuit analysis. Then circuit theorems. Circuit theorems means superposition, maximum power transfer theorem, Thevenin theorem, all the models, all these fundamental theorem, reciprocity theorem, these comes here. And your 2-port networks. So sure shot question from this. Circuit theorem especially, maximum power transfer theorem or Thevenin theorem. One question from this is 100%. So don't neglect anything, purely numerical question. There is no chance of any theory part. So try to focus on that area. And then we are having measurement systems. This is again subject coming from the measurement side. So mostly you can expect theoretical questions. So here we are having static and dynamic characteristics, error analysis, uncertainty analysis, data analysis and curve fitting. Mostly theory. That's the reason I did not mention much in the weightage part. Little bit of formulas are there. See the problems related with that and try to understand the error analysis. That will be sufficient. Right. Next. Coming to the next one. Sorry. Electrical and electronics measurement. So again, this is a combination of electrical as well as measurement. So we are having bridges, different type of bridges, potentiometers, how you are measuring voltages, then R, L and C measurements, voltage, current, power and power factor calculations, AC and DC probes and instrumentation ranges. Different ammeter, voltmeter, what are the ranges, how you calculate them, how you do the error analysis. So all this is the part coming from this area. And important power factor calculations, bridge problems and range calculations. Okay. Now coming to the electronic measurements. So here again we are having quality meter, waveform analyzer, digital voltmeter, multimeters, time phase and frequency response, cathode ray oscilloscope CROs, and serial and parallel communication, shielding and grounding. So how you can protect your elements, circuit elements, using this shielding method and grounding method. So from this also you can expect, but mostly it will be theory questions. Okay. So focus mostly on the first part. I have allocated 50 hours, 30 for the first part and 20 for the second part. Right. Next, we are having transducers, mechanical measurements and industrial instruments. Again, a little bit headache topic only, but still theoretical questions, 2 or 3 questions you can expect. And we are having transducers and measurements as one part, which covers resistive, capacitive and inductive. Piezoelectronic transducers are there. Measurements of displacement, velocity and acceleration, force, torque, vibration and shock. So pure ECE branch students may not even touch this subject in your engineering, but here you have to study a little bit. Try to focus on small numericals that are there in that area. And industrial instrumentation, these are the areas: measurement of temperature, pressure, flow and liquid level, measurement of pH, conductivity, viscosity and humidity. And here also expect theoretical bits. Okay. So this is a little bit different subject, but you don't have a choice. You cannot leave anything. That is a problem with these type of exams. Once they give the syllabus, the weightage will be from all the parts of the syllabus. If you are leaving means even though you do all the other questions correctly, still you are losing marks on this. So these type of examinations where you are going for a job, you are not actually going for higher study. So job means it is lifetime now. So there is no other chance for you. You should not give chance for another person to attack you. You have to attack in such a way that you have to crack that exam, that's all. There should not be any second thought. That is how you have to prepare for this type of exams. Because limited post, score maximum, and based on that direct job. So there is no other way, that is the reason you have to prepare to the fullest. And coming to the next one, basic electrical engineering. So this covers your total motors and generators, purely electrical branch subject. So again, series, parallel, star, delta, they have mentioned here. Already this part you are covering in your previous subject, the network subject. So here also they have mentioned almost the same points. First 4 are same, you can see. The last 2 are different: speed control, braking loss and efficiency. So you can expect questions from the subject on these 2 points. And coming to the last one, electrical circuits. There they are covering generators, motor, efficiency, induction, synchronous, different type of motors and generators. Here also importance should be given to measurement of power, instruments, measurement of energy, EMF calculations, AC machines and induction motors. So little bit of theory as well as numerical, both are there in this area. So electrical branch subject, focus on that. And I have allocated 30 hours only. I am not keeping much time because most of the things you study at this stage, whatever you study, it may look completely new. So try to focus on things which are more important. Wherever formulas are there, please make bullet points. Theoretical points also, understand them carefully. And revision time is most important. So study time is there. Along with it, try to focus or give more allocation for revision for these type of subjects. And coming to analytical optical instrumentation, this is having 3 parts. First one is nuclear measurements, where you are doing a mass spectrometry, UV and visible spectrometry, X-ray measurements. So purely theoretical, okay? Then optical sources and detectors, this is more important. That's the reason I have allocated more hours, because more realistic questions and numerical based questions can come from this area. So try to focus more on that area, giving more importance to that particular topic. So it covers LEDs, light emitting diodes, lasers, light amplification by stimulative emission of radiation, what are photodiodes, metrology applications, basics of OFC, optical fiber communication. So what is an optical fiber communication link? Starting from the source, cable and the receiver. So the total structure, how it is built up and what are the numericals, attenuation that can happen. These are the cases where you need to concentrate. And finally, microprocessors and microcontrollers. Already you have seen microprocessor earlier in digital. The same thing is again repeated here, but little bit more enhanced. So what they are saying, he is asking about Intel 8086 and 8088, interfacing, microcontrollers, and specifically 8051 real-time control. At least the pin structure and the voltages that you are giving, standard outputs. Those you have to remember. So these are the areas of questions that you can focus. But this is having more weightage also as far as my understanding is concerned when compared with other subjects. So try to focus time also in this manner, purely theoretical, so less time. Numerical chances are more, interesting topic, more time, and less time again. So based on the topic, I have divided the hours. So depending on your ease of preparation, you can change that as per your convenience, but try to focus in this order. And then we are having telecommunication, switching system and networks. Again, I am having three parts here. First is evaluation of telecommunication systems, where basic switching systems, whatever the packet switching, data switching, circuit switching, different models of switching you are having. Then whenever there is a congestion, how you are making arrangements for the traffic to move in that particular network. So routing algorithms, all these things will come here. Then when it comes to queuing system, what is queuing and how you are forming a delay table, means which unit has to be transported at what point of time, after how much delay, all these things will come here. Different type of switching networks, time division multiplexing and switching systems, okay. And finally we are having packet switching, analog networks, cellular and charging and routing. So these areas are also mostly theoretical. So try to focus more on theory in this particular area, okay. And last one is analytical, optical and instrumentation part. Sorry, I have covered this, this part. And general aptitude and numerical ability, this is the last one. So we cannot specifically tell this is the area that you need to focus, because any competitive exam, at least 1/5 of the total weightage will be there on this. So in your that 100 marks paper, they have given 20 marks weightage for this area. So these are different things coming under aptitude. So any fundamental book you refer, you will find this. And there is nothing related that you have to memorize and go. These are all your 7th, 8th, 9th max, okay. So that is the reason I kept 1 hour time only for this. Every day you do, don't wait till the last and do, then automatically you will get confused. So in this 45 days or whatever the time you are having, every day 1 hour you give this, and 1 hour will be nice if you do it first in the day. First complete this, then you go with the core subject. Every day you spend 1 hour, means 45 or 50 days, whatever time you have, 45 days, 45 hours, that is sufficient for this, okay. That is more than sufficient, in fact. So general aptitude, you are having all these things, time and work, trains, boats, time, distance, percentage and profit loss statements, ages, averages, partnership, number system, basic max formulas, simple and compound interest, letters, number coding, blood relations and directions, okay. And coming to the state formation, Telangana state formation, you are having its history, movement and in general. So 5 I have kept for hours. Don't go in depth, that's the reason I want to specify it here. So this is not any polity exam or UPSC exam. You know, you have to prepare minimum things, and that too, whether you get question on this or not, we are not sure. So that is the reason, minimum things, when it is formed, how it is formed, what are the different you know, things happened during its formation, what led to its formation, and standard movements that were there in the Telangana region. These things you try to figure it out. That would be sufficient. So these are the things from my side. We are having this classroom coaching at APPSC Center, and it is starting from 30th September. So whoever are interested, you can directly come and join, okay? And you will definitely get a very good discount. And if you are an old student of ACE, you will get straight away 50% discount. So time is very less. Even if you come here, the same logic we follow. Almost 8 to 10 hours a day class, remaining is your preparation time, self-preparation time. So even if you want to sit in your house and do, you do the same standard preparation which I tell you, okay? And try to focus on all the subjects. Don't leave anything. That is the first point. These type of competitive exams which are time bound, 100 questions, 100 marks, 120 minutes. There is no chance examiner is going to leave any subject and give you question. Every subject out of these 9 subjects he will touch and ask questions. So those who attempt the paper completely will definitely get a job. So that is the reason, focus on all the points. This 45 to 50 days, no rest. Think that you are working for your entire life and then proceed. Definitely you will be successful. So if you want to come sit in the class and learn with us, then enroll in this program. It is a time bounded program, maximum 45 days. We are very much clear on that, because if you go further also, it will be no use for the student. So covering all the points in the syllabus is important, covering in quick time is important, as well as giving sufficient time for the student is also important. So we follow that very regularly in these competitive exams. So if you want to come and join with us, you can straight away come and join in this batch. Okay. So that's all from my side. Let me take you through some questions which are given in latest papers. We are having still 20-25 minutes. So I'll just go through these questions and see what is the level of questions that were asked, so that you will also have an understanding at what level you are actually in and how much you have to prepare. Okay. So whatever I have discussed till now is only the syllabus and a preparation strategy for the coming 6 weeks. So now what I am discussing are the questions that are already asked in the exams, your GENCO Transco papers only, and some questions which I am expecting from my side. Okay, I will not take much time. Some 8 or 10 questions I have taken. I'll just go through those questions and let us see how you can answer those models. Okay, right. Yeah, see these questions. If the system has multiple poles, so whenever you read a question, especially in these type of papers, read question completely, clearly. There should not be second reading. If you read the question second time, means you are wasting your time. So whenever you read the question, it should be done completely, it should be done clearly. So what is the point here? It is having multiple poles. Multiple poles means what? At least 2 or more than 2. That is actually multiple means more than 2. Okay. On the j omega axis system is. That means what is he saying? You know very clearly. This x-axis is your sigma and this y-axis is your j omega. First order poles are there. Then definitely it is conditionally stable or marginally stable. More than 2 poles means a second order pole, or at least more than 2. More than 2 means these are all complex conjugate poles. So at least 4 should be there, or these 2 poles might be repeating also at the same location. Suppose let us assume this is plus j1, so this will be minus j1. This is plus j2, this will become minus j2. So these are more poles only. This comes under the category of multiple poles, or it might be like this also. This is your real axis, imaginary axis, repetitive pole, complex conjugate and repetitive. That means I am taking plus j1, 2 poles are there, and minus j1, 2 more poles are there. Both these are satisfying that condition. Definitely unstable, no doubt. So your answer should be D. So this clarity should come when you read the question only. You should not think twice. You should not read the question also. That is how you have to prepare. Next, let us see the next question. Sine wave can be converted into a square wave using which circuit? So basically what is the meaning here? The output of my circuit must be a square periodic waveform. Sine wave, is it periodic or not? 100%. So square wave, whatever he is asking, should also be periodic. Inherent condition. So which circuit will give you? You know, Smith triggers are square periodic waveform generators. Straight away that answer should come before seeing the options only. Go with that, that's all. Don't read the remaining things. Maybe monostable, astable multivibrators are also square periodic waveform generators. But the one which converts from sine to square is obviously Smith trigger. Based on the circuit parameters R and C, you can fix the period. Theoretic question. So just stick with that value. Next. In RC integrator circuit, the output is taken across. See how simple question was framed. What is he saying? He is saying 2 points here. One is circuit is having R and C elements. Another is he is saying that it is integrator. Integrator means is it a low pass filter or not? That means what? He is talking about a first order RC low pass filter. That's all. So what is a first order RC low pass filter? You will have resistor in series arm and a capacitor in parallel arm. So this is your R and this is your C. So you are having input given across these terminals and you will have voltage taken across these terminals. So on what branch you are taking the voltage? You are taking voltage on capacitive branch. Finish. So your answer should be. So this much drawing is also not required. That RC circuit should immediately come in your mind. Just by imagination you tell that answer, that's all. That is how you have to write. Next, 3 equal resistance of 3 ohms are connected in star. So here all resistance values are equal and how are they connected? Sorry, star. That means what? This is a circuit. Star connection, na? All these values are equal. 3 ohms, 3 ohms and 3 ohms. Now what is he saying? What is the equivalent resistance value when you take its equivalent delta? So is this equivalent delta or not? So whenever you convert from star to delta, if all the star value of impedances are Z, then its equivalent impedance in delta will be 3Z. You are moving from inside to outside. So this value will be 3 into 3, 9 ohms. This is also 9 ohms and this is also 9 ohms. If you come from outside to inside, means delta to star, value of impedance Z in delta will become Z by 3 in star. So your answer is obviously 9. So that is how you have to mark it very quickly. You need not draw this also. Just because I am explaining, I am drawing. Okay? Next. A circuit contains, see this question carefully, very good question. Dependent voltage source. So dependent, that is a keyword here. And 2 resistors. So it's purely a resistive circuit. The Thevenin equivalent is to be found across one of the resistors. The resulting Thevenin equivalent has. So whenever your network is having only dependent sources, what do we call that network? These networks are also called as source-free circuits. Dependent sources are not active throughout the time. Once that energy is consumed, they become passive. That means you are dealing with a source-free circuit. So for a source-free circuit, what the circuit will have? It will have only R equivalent. Because he is saying it's a resistive circuit. If they are connected in series, R1 plus R2, parallel, R1 parallel to R2. Except that there is no possibility of any voltage or current source. So which will be your correct choice? A voltage source, no chance. Current source, no chance. Only resistors. That is the correct. Very clear. Circuit is having only dependent source. Based on that, you have to mark your answer. That is a keyword here. Okay. This is coming under Thevenin theorem. Thevenin, we are having 3 models. Circuits having only independent, circuits having both independent and dependent, and circuits having only dependent sources. So this comes under the 3rd model of that Thevenin. Okay. So in class generally we classify them in this way and tell, so that the students in examination can easily recollect and straight away go with the option. That is how you have to master yourself. Okay. Next. Now see this question. The output voltage of the circuit purely numerical and it's based on an ideal op-amp. So I think this gain is infinite. So whenever you see this infinite gain, the meaning is it is ideal op-amp. Okay. So he is asking what is the output voltage. So this is your V out. Now see here. What is the characteristic of an ideal op-amp? Whatever the voltage that is there here, the same voltage should be here. Inverting and non-inverting terminal voltages are same. Now this is grounded, means it is 0 volt. That means this is also 0 volt. That is a clue. Now you write one nodal equation at this node. You don't know the direction of the current. Assume outside. So what is that nodal voltage equation? 0 minus 500 milli divided by 1K, current flowing on left side branch, plus assume current flowing outside only when you don't know the direction. Current flowing in this branch 0 minus V0 divided by 10K resistance is equal to 0. That's all. No need to check whether it is inverting mode, non-inverting mode, all that headache. If you memorize, you will do like that. If you understand the concept, this is a simple equation. So your LCM is 10K, so this automatically becomes minus 5. You will get minus 5000 into 10 power minus 3. So it is nothing but minus 5 minus V0 equal to 0. So therefore, what is the value of V0? Automatically it becomes 5 volts. Finish. So your answer is minus 5. So V0 is minus 5 volts, negative. Okay. See how easily you can mark your answers. Don't use that formulas of minus RF by R1, 1 plus RF by R1. They are correct only. But if you are having these type of techniques, you need not memorize those things also. So ideal op-amps are clearly mentioned in your syllabus also, and their applications like V2A, I2V converters, voltage follower, differential amplifier, these type of things which are there in the standard books, please refer to this. And one question is definite from this area. So don't leave this particular topic. Operational amplifiers, that too ideal op-amps, very, very important. Refer all applications. They will be very, very useful. Sometimes theory bits may come, sometimes numericals like this can also come. Okay, so one sure shot question from this area. Ideal op-amps is must. Right. Next. Which of the following consume minimum power? So what is the concept here? You have to consider the circuits taking a least power. Out of this, which one will take least power? Least power combinations will come whenever you are having combination of NMOS and PMOS. That means definitely it should be CMOS. There is no other chance. Now sometimes they may ask which one is taking a least time or very fast outputs. So these are nothing but your TTL, transistor logic. These are all coming under gate families. One question generally in competitive exams comes from here. Diode transistor logic, resistor transistor logic, complementary metal oxide semiconductor, transistor logic. CMOS minimum power requirement, TTL speed is very high. These 2 points are very, very important. And what logic families they denote, and where you take the output, what is the standard input, these type of things. Propagation speed, propagation time, delay, which one is less, such type of things you try to get hold of it. So one very, very important area. Next, two systems with impulse responses H1 of t and H2 of t are connected in cascade. Signals and systems question. Overall impulse response of the cascaded system is dash. Means what is he saying? You are having some input. You are considering two systems. One is a H1 of t impulse response, and whatever the output you get is given to another system which is having impulse response H2 of t connected in a cascade. Now let us assume the overall output is Y of t. So what he is asking, what is the impulse response of the overall system? So when you have two systems connected in cascade, he is saying two systems are connected in cascade. Then the overall impulse response will be H of t, which will be always convolution of H1 of t with H2 of t. Star symbol represents convolution. If they are in parallel, H1 of t added with H2 of t. Series, H1 of t into H2 of t. When they are connected in cascade, it is H1 of t convolved with H2 of t. Okay? He did not ask any numerical, just a simple thing. So it is always convolution process. Okay? Next, the Fourier transform of a rectangular pulse of width tau seconds and having unit magnitude is dash. It's also a standard bit. So whatever the signal he is talking about is a rectangular pulse. Rectangular pulse means we write RECT. He is talking about the pulse in time domain whose width is tau. Sorry. So the total width is tau and the amplitude in this range is 1. A value is 1. So if you take this pulse, it is a symmetrical rectangular pulse, x-axis is tau. From where to where it is existing? Sorry, x-axis is a t, not tau. This is t in seconds. Total width is tau, so it should be from minus tau by 2 to plus tau by 2. And in this range, the amplitude is 1. So the standard logic here is very simple. All rectangular pulse transformations are sinc functions. So first write a sinc function in frequency domain. Now the quotient of f is the width, which is nothing but tau. And the coefficient of sinc function is total area. What is the total area? Base is tau, height is 1. So it is tau. So the component of sinc function you are writing is area of time domain signal. And the coefficient of this function f, whatever you are writing, is total width of time domain signal. That is a shortcut. So any type of question that is framed, you can easily answer. So what will be your answer? Your answer is tau into sinc, tau into f. Okay. So easily you can mark your answer. So all are, you can remove this, you can remove this. So tau into sinc, tau into f. I don't think pi is there, it might be a printing mistake. So you can go with this choice. Pi will not be there. Clear? Next, the Z transform of a sequence u of n minus u of n minus 2 is dash. So basically what is a Z transform for a unit step sequence? For u of n, Z transformation is 1 by 1 minus Z inverse. ROC I am not writing, question is related only with this. So for u of n minus 2, what will be the transformation? Using time shifting property, this would become Z power minus 2 by 1 minus Z inverse. So what is he asking? It is the difference of this u of n and u of n minus 2. So when you subtract sequences in time, you can also subtract their individual transformations. So it becomes 1 minus z power minus 2 by 1 minus z inverse. So you can write this numerator as 1 minus z inverse into 1 plus z inverse whole divided by 1 minus z inverse. So this and this will get cancelled. So the value will be 1 plus z inverse. That is the answer. So your correct choice will be 1 plus z inverse. So depends on the type of numerical. Some questions are very easy. Some questions you have to do it 2-3 steps. So depending on that you have to attack. But there is no chance of leaving these type of questions. They are very, very scoring. Next, in amplitude modulation, dash of total transmitted power is used for carrying message signal under best conditions. So what is the standard AM expression for power? PT is PC into 1 plus mu square by 2. This is a standard expression. And if you take the modulation efficiency, this is mu square by 2 plus mu square. Okay. Now, when nothing is specified, generally the assumption which we make is the message signal m of t is a single tone signal, means either periodic sine or periodic cos. And the value of modulation index is 1. So if you take that case, the value of modulation efficiency is 1 by 3 or 33.33%. Means what is the meaning? 1/3 power you are utilizing on transmitting message. That is what your modulation efficiency tells. How much power you are utilizing in transmitting message when compared with the total power. So here 1/3 power I am utilizing on transmitting message remaining 2/3 power I am utilizing on transmitting carrier. That is actually wasted power. So what is he asking? In amplitude modulation, dash of total transmitted power is used for carrying message signal under best condition, means 1/3. 1/3 means how much? 33.33%. Nearest answer is that. So that is how you can easily track these numericals. Which modulation scheme uses Hilbert transform? So Hilbert transform is used only in SSB. So what is a modulated signal expression? If you take S of t of a DSB-SC signal, sorry, SSB-SC signal, we are having AC by 2 m of t into cos 2 pi FCT. It will be either minus or plus AC by 2 m cap of t into sin 2 pi FCT. That's all. So here m of t represents message signal, m cap of t represents Hilbert transform of message signal. Only in SSB you will get this m cap of t. And if you write minus, the meaning is you are doing transmission of upper sideband. If you write plus, meaning is you are doing transmission of lower sideband. That's all. So this is how you can easily get this value. Next, let us see one more question. This is also on communication only. A PCM system uses Nyquist sampler. Means what is the meaning? He is saying that the sampling frequency used is a Nyquist frequency, means twice the maximum frequency of your message signal, minimum sampling frequency. A uniform quantizer followed by a 5-bit encoder, means the number of bits you are using in the encoder is only 5 bits. The bit rate is 50 Mbps, so this is giving you the value of RB. Means what is the bit rate formula in PCM? RB is always equal to N into Fs. That means this value of RB is given to you as 50 megabits per second is equal to the value of N is how much? 5. And what is Fs? It is twice the maximum frequency of message signal. That's all. Substitute in this formula. Now what is he asking? The maximum message signal bandwidth for which the system operates satisfactorily. Message signal bandwidth means what? It is representing the maximum frequency of your message signal. Message signals are low frequency signals. So the maximum frequency of that signal itself signifies its bandwidth. So what will be this value? Therefore, the maximum frequency will be 5 megahertz. So that will be the bandwidth of your resulting signal. So your correct choice should be B. That's all. So all these what you can see here, most of the questions are numerical from communication but formula based. And questions coming from signals are also the same way. And you can see digital questions, operational amplifiers, sometimes these will be numerical and sometimes theoretical. So depending on the syllabus that you take and prepare, these things will come out. So numerical definite attack you can do, there is no doubt, but other papers like coming from measurements, electrical, theory related questions are also more important. That is how where you can score maximum. So these are some areas which I have taken. These are questions given in your previous papers only, and some questions I have added to that. So try to understand these points carefully, and it's not so complicated because whatever things which you are studying here, if you can do that preparation for the coming 6 to 7 weeks, definitely you can complete the total syllabus. There is no doubt about that. Okay, so try to focus as much as you can. Whatever I have given, 5 plus 1 plus 2, 5 for core subject, 1 for the aptitude part, 2 for revision. This consistently if you do for the coming 6 to 7 weeks, definitely you will have a very good success. So I wish you all the best for your future endeavors. Thank you.